Hello everyone. Yeah, today our topic is vertical circle actually. So without wasting our time, let's start our topic. So for example, we are taking that there is a body of mass m and it's attached with a string of length r. Let's take it r. Why r? Because we are doing it, we are assuming that it's performing a vertical circle. So this r can be taken as the radius of that vertical circle. Okay. So let's draw a circle here, actually. So if I am drawing a circle here, so there is an object which is attached to a string. This object has mass m. This string has a length r. So this r is actually the radius of this vertical circle actually. So this body is doing a vertical circle. So on this concept, there are several questions, there are several numericals asked in our examinations. Okay. So what's the basic thing here? We have to find the velocity, the minimum velocity given to this body, this mass m in this position here. So for example, we are given it a velocity v. What is the minimum value of this u actually? What is the minimum value of u given to this body such that it performs the vertical circle? For example, let's take an example here. Actually, I am not having a string actually here. This is we can say that this is the rod. The concept is same actually, but the values will be different in case of rod and in case of string. But here we are only looking into this. For example, this is the body. This is the point. If we are given this point some initial velocity in this direction here, okay, so it goes up to this and comes back. If we are giving the velocity, more velocity here, more speed here, so it goes up to this height. So we are giving more velocity, yeah, like this. This completes this circle here. So there is some minimum velocity required at this point such that body will complete its circular motion, vertical circle. If I see at this diagram, if at this circle there is a critical point, we can say that there is some point. If body crosses that point, then surely it will be doing this vertical circle. So by common sense, we can say that that point is actually, this much is that point. If body crosses this point, then obviously it will do this complete circle. It will do the complete circle, and this point is called as critical point. So let's discuss about this critical point. What is the criteria to cross this critical point? What is the criteria to cross this critical point? Actually, here in this string there will be a tension T, obviously. So this is the main reason, this is responsible for completing the circle. This T is responsible for this body to complete the circle. We can say that in this condition here, we can say that obviously body is moving with u velocity, u speed, so there will be a force mu square divided by r, that is the centrifugal force which is always away from the center. So here will be the force mu square divided by r. And there will be its weight also in this direction. So it will be mg. So here in this case, tension will be equal to mu square divided by r plus mg, no doubt. But as you are going upside, the speed of this object will obviously decrease. Why? Because there is a gravitational force. Okay, gravitational force is doing downwards work now, and this is going upwards, so the work done by gravity will be negative, obviously. So its speed will decrease. But at this point, let's assume that body has some velocity. At this point, body has some velocity v, and at this point the string is like this, so tension is in this direction here, and the centrifugal force will be mv square by r, that will be in this direction. And what about weight? Weight is always downwards, so this will be weight in this direction. So here we can say that tension is tension increasing or is tension decreasing from this point to this point? Obviously tension is decreasing. Okay, so tension is decreasing. So to cross this critical point, we can say that the tension should be greater than 0 because the string is responsible for this circular motion. Okay, we can do a practical about this, that we will have a string, we will have a ball attached to it, then we will see that the body is moving, there will be some tension in the string. So the tension in the string should be greater or equal to 0 for completing this circle. So for the vertical circle, to complete, tension should be greater or equal to 0. Where? At critical point or at maximum position. Okay. Now, some students are asking that, sir, no doubt, tension greater than 0, we can understand this. But what about tension equal to 0? Sir, why have you written that tension equal to 0? Still the body will complete the circular motion. Okay. That the reason is, at this point, if the tension is equal to 0, but we have given that here there is some velocity to this body. If the body is having some velocity, obviously it has some inertia of motion. So by the inertia of motion, it will go a little bit further, okay, in the forward direction. Then there will be tension and it will do a circular motion. Okay. So this is the condition that body should have, that the tension at this point should be greater or equal to 0. If this happens, then body will complete its circle. So for that value, for this to be happen, we have to find u. We have to find the minimum value of u for this body at this position such that it completes a vertical circle of radius r. Okay, beta? Okay. Let's start now. As we have already discussed our work energy theorem, there we find that the work done by all the forces is equal to the change in kinetic energy. Okay, let's start our topic now. Okay, for example, if I'm assuming some points here, let's name some points here. Let this point be A. Let this point be B. What happens between A and B? For example, any position. Let's take this position at theta. The body is here. So this will be its weight, this will be its tension, and in this direction let the velocity be v dash. For example, it was u, now it's v dash. So the centrifugal force will be away from the center, so it will be in this direction, m v dash square divided by r. If this is theta, this is also theta. So here we can see that the component of mg will be in this direction, that will be, the component of mg in this direction will be mg, theta is here, so it will be mg cos theta. So at between A and B we can say that between A and B, what happens to the body, the tension is equal to mg cos theta, okay, plus mv dash square divided by r. So this is the tension, what happens to the tension between A and B. So here theta, actually from A to B, what happens to the theta? It is increasing. The theta is this with the vertical direction, downward vertical direction. So theta is increasing. If theta is increasing, what happens to the cos theta? Actually, this is in the first quadrant. Theta lies in the first quadrant here. It can be from A to B. It can be from 0 to 90. So it's in the first quadrant. And in first quadrant, cos theta is a increasing function or decreasing function? Obviously, it is a decreasing function. So if theta increases, cos theta decreases. That means this thing decreases. Obviously, velocity of the body, speed of the body, it also decreases. So we can say that between A and B, what happens to the tension? Tension decreases. Between A and B, tension decreases. Okay. So we have to, if in the question we are asked to find out the tension between at any point between A and B. So we can find it by this formula. The tension is equal to mg cos theta, and what is the angle cos theta? We can find it here. So So it is mg cos theta plus mv dash. What is v dash? Is the speed at this point. Now there is a question how we can find this v dash. Okay, we can find it by work energy theorem. I will discuss it later. So here we can find the tension. Okay, so tension is increasing. Okay, after point B, let's take the another point C, that critical point actually. Let's name it C. So after B, let's take any position, this position. Let's take body here. Let its velocity will be v dash. Let the now theta with this vertical here. Okay, now this is the vertical, with vertical is theta. So here this will be tension. This will be your weight mg, and this will be your mv double dash square by r, centrifugal force. Now here, if we equate the forces along the radius, so we can see that if this is theta, this is also theta. Okay, so here t plus mg cos theta. So this is between. Now we are asking between B and C. So t plus mg cos theta. This mg and this is the angle theta. So here its component will be t plus mg cos theta will be equal to mv dash square by mv double dash square by r. So tension here will be equal to mv double dash square by r minus mg cos theta. So this is the tension between B and C. Now here, what happens to theta? When you are going from B to C, what happens to theta? Theta is going from 90 to 0. So theta is again in first quadrant and it is decreasing. And if the theta is decreasing, that means cos theta is increasing. So this number is increasing and obviously speed decreases. So this is decreasing and this is increasing and there is a difference between them. So obviously tension again decreases. Obviously tension again decreases. So here we can say that tension decreases. So from this point to this point tension always decreases. At point C, now we can say that at critical point this condition will follow. At critical point then we will find the velocity. Okay, let's move the other page. Let's make circle again. Let's have this position at critical point. At critical point, let's assume the velocity is v, tension is t, and mg is in this direction. So here it will be mv square by r. So we can say that tension at point C, we are asking about at point C, we are discussing about point C, that is the critical point. So we will say tension plus mg will be equal to mv square upon r. So tension will be equal to mv square upon r minus mg. This is the tension. Okay, now here we have to find B. And we know that for completing the circle, this tension should be greater or equal to 0. So that means this mv square by r minus mg should be greater or equal to 0, obviously. Now how we will find B? How we will find B? So we can find it by work energy theorem. So let's think that we know the velocity at here. We are dealing with the velocity at this point, let that be here. We know that, okay? So from this point to that point, let's take a reference line, gravitational reference line. Let this be the reference line. That means reference line here, if we are taking the reference line here, we will assume that the gravitational potential energy here will be 0. Okay? So by applying work energy theorem, we know that work energy theorem, that work done by all the forces. How many forces are there? There is one force is mg and another force is tension. So we can say that work by mg plus work done by tension is equal to change in its kinetic energy. So that's K final minus K initial. Now here work done by tension is actually 0. We can see that here. The tension is always perpendicular to the displacement of the body. So that means work done by this tension is always 0. Or we can say if see that in pseudo, if we take this pseudo force, that centrifugal force, if we are looking from non-inertial frame, we will consider that pseudo force also, and that work done will be again 0 because that's also perpendicular. Okay. So work done by this tension will be equal to 0 because of that displacement and force, they are always perpendicular. So we can say that work done by mg will be equal to K final minus K initial. As we can see that work done by mg actually is weight, and that weight is conservative in nature, and we know that work done by conservative, we already discussed, that is equal to minus times change in potential energy. So we can write it, in place of this we can write it minus times change in potential energy, this is U final minus UH, is equal to K final minus KH. From here I can see that this is plus UI, this is minus UI. If I put minus UI in this side, so it will be UI plus KI. UI plus KI will be equal to K final. Here this is minus U final, it will go this side, it will become plus U final. So this actually is nothing. This is mechanical energy. Initial potential energy, initial kinetic energy is nothing, but it is mechanical energy. Initial will be equal to kinetic plus potential final will be mechanical energy final. Okay, wait. Now this is the initial condition and this is the final condition. Now if I look at this initial condition, here we are taking this as reference line. So there the kinetic energy will be 1 by 2 mu square plus potential energy will be 0, will be equal to, and the final condition is here the kinetic energy will be 1 by 2 mv square, this is the v which we have to find, and plus potential energy will be the, what is the height, this is r plus r, that's 2r, and the force is mg, so it will be mg, h is here 2r, so it will be mg 2r. Okay, wait. Now here we have to find actually here we have to find this v, so we will get here mv square. From this equation we will get mv square. So our mv square will be equal to here mv square will be equal to, multiplying this equation by 2. This will be and this will be and this will be, cut it down mv square, so it will be mu square minus 4 mgr. This is your mv square. Now put the value of mv square here. Actually, see, mv square is in terms of u. We know u. It's in terms of mgr. We know mgr. We know m. So we will put this mv square in this equation. Let this equation be the equation first. So put the value of mv square in equation first. So our equation first will be this mv square. In place of mv square we can write this, that's mu square minus 4 mgr divided by r minus mg should be greater or equal to 0. Then this is r, so we can say that mu square minus 4 mgr minus mgr, r into that will be 0. So this comes out to be mu square minus 5 mgr should be greater than 0. So we can say that mu square should be greater or equal to 5 mgr. Mm gets cancelled, so we can say that u square next way, u square, u will be greater than under root 5gr. So we can say that u will be greater or equal to under root 5gr. This is the velocity required for the body to complete the circular motion. If the velocity at this point is either equal to under root 5gr or greater than 5gr, we can say that surely body will complete its vertical circle of the radius r. So this is the velocity. So we can say that minimum value of u is under root 5gr. Okay, beta. For example, we are saying that a body of some mass m is independent of mass actually. You can see here it's independent of mass. Whatever it has mass, it's independent of mass. The velocity is under root 5. It only and only depends on this radius. If I say you that the radius of this string or the length of the string is for example 2 meters. So what is the minimum velocity required such that it will complete its vertical circle? So it will be u minimum will be equal to under root 5. Let's take g 10 into 2. Okay, so it will be u minimum will be 10 meters per second. So here if I given 10 meter per second, it will just complete its circle. It will just complete its circle. If the velocity will be less than 10, it will not complete the circle. If it is more than 10, it will definitely complete the circle. And if it is 10, then it will just complete the circle. Hope you understood this topic. Thank you.